29th, I think. Can you see, please, from the back? Mike? Can you see? Mike or Michael? Mike, okay. Good. So the problem, can you?
It was 29.
Okay. Can I see it?
Yeah.
Let me copy it. Problem 29. We want to look at a division. So this is a division. 144 b squared minus 25 everything over 72 b squared minus 6b minus 10 and divided by 18b squared minus 21b plus 5 over 36b squared minus 18b minus 10. Is this the problem? Okay, perfect. So this is our first question, and we're asked to fully simplify this division of two rational expressions.
What number are you doing?
29, is it?
Yes.
29. Was it 29 from 1.6, or is it from the book, or
It's from 1.6.
from the assignment in WebAssign?
Oh, that was from the book.
Okay, that's fine. But you had the assignment from 1.6 in WebAssign for today. But that's fine. It's a perfect example. Okay, so let's work on this. We can factor the numerator immediately, right? How do we factor the numerator? Right, difference of squares. So that will not be a problem, right? So 144b squared minus 25 will be 12b minus 5 and 12b plus 5. That's the first one. Now let's take a look at 72b squared minus 6b minus 10. The strategy for factoring, let me refresh your memory. The first step, if you're giving me this polynomial to factor, my first thought is to ask myself, what is it? And my answer obviously is a trinomial. Then I'm looking at it and ask myself, is it in descending order? The answer is yes. The third question, mandatory, you could never skip these steps, any of them. I'm going to ask myself if there is a greatest common factor, and I have to say yes. There is a greatest common factor, which is 2. If we don't factor the greatest common factor, it will be, we make our life more miserable, or more difficult, if you want. So this is 36, b squared minus 3b and minus 5. Now, what I recommend, we will factor this, but what I recommend when the numbers are so big, because now we are trying to find two numbers whose product is 36 multiplied by negative 5, and whose sum is negative 3. When numbers are so big, I recommend quadratic formula as one option. The second option would be, so instead of really multiplying these two numbers, I would factor them. I don't really care about 36 times 5. It's a huge number. But 36, I know, is 4 times 9, and then a 5, and then this is 2 and 2 and 3 and 3 and 5. These are the prime factors. Prime factors in this number, huge number, 36, whatever that is, 36 times 5. 180. So now I know that since the product is negative, I'm looking for a positive number and a negative number, mandatory. And since the difference between the two numbers is only negative 3, the numbers cannot be 2 or 2 and 500, right? They have to be very close to each other because the difference is only 3. They're only 3 or minus 3 apart. So let's see how we group these factors to get two numbers that differ by 3 in either direction. Of course, the answer will be negative. So the bigger one will be negative. In absolute value will be negative. So what do you think? Say it again. We have to use all factors. We have to use everything we have here. Right? So here's what we're looking for. Right? The first group is 12. The second group is 15. Their difference is 3. So then we will continue with 2, 36b squared plus 12b minus 15b and minus 5. I don't really want to spend too much time on factoring these huge numbers, because it's really not that useful. I mean, yes, it's a good technique. Yes, you want to see it once or twice, but I'm more interested in concepts more than just plugging in some numbers and coming up with 15 and 12. So my focus is more on concepts than huge numbers, because we have alternatives. And the alternative is to use the quadratic formula, and you'll find the solutions in a blink. So that's not such a big deal, right? So now we have to factor by grouping. So from the first two, you will factor out
12B.
and in parentheses 3b plus, yes, what should we get from the other two? We have to get 3b plus 1, otherwise we can't continue. It's mandatory, right? These have to be the same. And now I look. I know they have to be. How do I know? Because I found the two numbers whose product is this and whose sum is negative 3. So I have no doubts. So now I need a sign and a factor, which is, what are? Negative 5. So then this is 2, 3b plus 1, 12b minus 5. You understand that a problem like this on a test will take 10 minutes. And I will be testing one concept, basically, factoring, instead of testing division and multiplication and many others. So a problem like this is not useful on a test situation. It's okay for homework, but not for a test situation, okay? So we finish with the second one. Now, in the same way, we'll have to deal with the other two. Do I have to continue, or is that okay? Is there any of these two that you would like us to factor? Because I don't want to just leave it if you have any questions. Again, here we have to factor out the 2. But the procedure is the same. And once we determine all factors, then we will have to state restrictions for these two polynomials, of course in a factored form, and then multiply and then state restrictions for what we get. But finishing up this problem is interesting, but it will just take a lot of time. I'm more than willing to do it if you want me to, though. I don't want you to feel that I want to cut it in the middle.
I'm fine.
You sure?
Yes.
Okay. Your question now.
It's fine, I'll get it.
Oh, why? I didn't mean to hurt your feelings or anything. I hope you'd know that.
It's just number 10 on the handout, I don't get it.
Oh, yeah. On the handout. Let's take a look.
I don't get what this is.
Yes, let's take a look. Number 10 on the handout. Good. So 2 over x plus 1 minus 2x over x minus 1 equals negative 4 over x squared minus 1. Very good. So first of all, I will move everything to one side, factor x plus 1, x minus 1, and write 0 on the other side. Are we okay, everyone, with this first step? Yes? Okay, perfect. I will have to state 2 restrictions. Can anyone give us 2 restrictions here?
And negative 1.
Very good. Can anyone give us the least common denominator? Can anyone give us the adjustments? What do we multiply the top of the first fraction by? For the second one. Excellent. And for the last one, you can leave it blank or just say 1 because they are the same. And now the numerator. 2x minus 2. Next.
minus 2 squared, minus 2.
Good? Very good. Okay, let's combine like terms and see what happens next. And let's try and factor. So negative 2x squared and plus 2 over x plus 1, x minus 1 equals 0. Is this okay so far? 0 over 1. We cross multiply. And we get negative 2x squared plus 2 equals 0. In agreement so far? Are we okay? Is this okay every step? So then we have negative 2x squared equals negative 2 and x squared equals 1. We haven't discussed taking square roots. That's one option. The other one is move x squared, move 1 to the other side because it's quadratic and factor. So we have x equals negative 1 and x equals 1. But these come with huge question marks because I know that I had to state the restrictions from the beginning, and it turns out that what I get is exactly what I can't accept. So what do we conclude about this equation? Has no solutions. Equation has no solutions. It is crucial, and I'm kindly asking you and begging you to redo the problems we do in class first, all of them, till you understand them perfectly, because otherwise you're going to stumble from the first problem, or it's possible that you'll stumble from the first problem you try to solve. That's the first layer of understanding and learning. Redo all problems we do in class before you do anything else. Or you may want to read the book before and do some examples from the book before you read our notes. But please find the time to read and redo the problems we do in class, because we have to cover a lot of material. So yes, next question, please. You had one.
Number 5.
From? Okay. Is it different than what we just did? Because if it's a similar problem, then I'm sure you understood what to do, unless you want me to.
Okay, I'll try.
Is it the same?
Yeah.
Yeah, potentially. What did they come up with the answer? They said it's negative 4. I have no idea. I've never worked on the problem. What did they say for the last one? Oh, the empty set. Okay, so they presented, or maybe that was not clear. This symbol is the empty set. It's the Greek letter phi, which means no solutions. There is nothing that works in that equation. The equation is called a contradiction. There are several types of equations, and this one is contradiction. There is no solutions. Are you sure you're going to be okay with that one? Or you want me to?
Mine was number 5.
Yes. Okay, let's do number 5. So we have x plus 5 over x minus 2 minus 5 over x plus 2 minus 28 over x plus 2 x minus 2 equals 0. So I skipped the first few steps, and x does not equal plus or minus 2. Is this okay so far? Yes? So then the least common denominator is x plus 2, x minus 2, and x plus 2, x minus 2, and just 1. So this is x squared plus 2x plus 5x plus 10. You have to use FOIL here. X squared plus 2x plus 5x plus 10. At the first look, I thought it was different, but I think we should work on this one because I don't think we've seen one like this. So this is a product of two binomials, so we have to use FOIL, x squared plus 2x plus 5x plus 10. And here I have to distribute negative 5, negative 5x and plus 10, and then minus 28. Is everyone okay with this? Yes? Any questions on this? Is this better now? Do you have any questions? Okay, perfect. So then I only see that these two go away, and we have x squared plus 2x, and this is 20 and negative 28, so this is negative 8. So x plus 2, x minus 2 equals 0 over 1. When we cross multiply, we will get x squared plus 2x minus 8 equals 0, and we will factor. And we get two options, as negative 4 and positive 2. However, positive 2 must be excluded. So the only answer is negative 4. What did they get? Negative 4. Is this better now? Is there anything else that you would like to ask? Yes, please.
Number 11 on the weather sign.
Okay. So we have 6a plus 1 over 3a minus 4 plus 3a minus 4 over 3a plus 4. And everything divided by, you may get probably a slightly different problem. Over 9a squared plus 16 divided by 9. Thank you. So this is called what? This is a very good complex, yes.
It's divided by 8 at the bottom, it's not 9.
Oh, a, thank you. This denominator. Sorry. Thank you. Good. Thank you. Okay, it's a complex rational expression. How do we start? Yes, because the denominator is already a fraction. There are no operations in the denominator. Good. So I will state 3 restrictions for now. A does not equal plus or minus 4/3, and a does not equal 0. And then we continue by finding the least common denominator at the top, and just copy the denominator and leave it as is. Can anyone give us the least common denominator at the top?
3 Is that like 3a minus 4 times 3a plus 4?
Perfect. 3a plus 4, 3a minus 4, and accordingly the adjustments will be 3a plus 4, 3a minus 4. Agreed with that? Yes? Okay, so now careful how we FOIL. So 18a squared plus 24a plus 3a plus 4. That is the first product, the first FOIL of 3a plus 4 and 6a plus 1. And then plus 9a squared minus 12a minus 12a and plus 16. Let's see if we can get rid of anything. Yes, okay, the 12a with the 24a, at least that. And then we have 27a squared plus 3a plus 20 over 3a plus 4 times 3a minus 4 and times a over 9a squared plus 16. Did I copy the problem correctly? Was this a plus?
Yeah.
Okay. I don't see any possible simplification other than writing them side by side. There is no additional restriction from this. This is always positive and never ever 0. 27 plus 3a plus 20 is not factorable. I don't see anything else. Just writing a in front of this, putting parentheses, and putting this in parentheses. I don't see anything else. that we can factor or simplify. That was the only thing. It's 27, it's a 3a, the only one left over, and 20. I flipped the denominator, that's it. I don't see anything else. So I will rewrite it by simply putting a in front, 27a squared plus 3a plus 20, and all these three side by side. 3a plus 4, 3a minus 4, 9a squared plus 16. Now, I could, I'm sorry?
Can you simplify 9a squared plus 16 in the?
It was something else? It was minus?
No, I'm saying, can you simplify that or no?
No. No. We only simplify factors. We can't simplify anything in terms. So I don't know if they presented the answer like that or they multiplied these, which we normally don't do. We don't do that. So I don't recommend doing anything else here. Very good problem. Anything else? Are we okay with this? Yes?
Which problem was that, or what was that?
It was, I'm not sure. Number 11. Okay, so let's get back to the agenda then. Yes? Yes? So I'm hoping you've finished the handout. You don't have any more questions. Yes? Is that a good assumption, correct assumption? And 1.6 in WebAssign is finished. Yes? If you didn't, please do it quickly. Yes? Yes, everyone? Okay, perfect. So here's where we are. We didn't accomplish much. Well, I think we did, but you know what I mean. So we will continue now with 2.1, and we will talk, bless you, we will talk about the distance formula, the mid formula, and the equation of the circle. And then we're going to look at this few examples from this handout. I did not make a copy because it has 30-some pages, but it's posted. And I'm going to show you some examples from the very end of the handout for circles. Okay, so 2.1. We're going to talk about distance formula. A midpoint, circle. Of course, the equation of a circle. So let's look at the distance formula. This is a quick review for you. It doesn't matter. I'll do it anyway from scratch. Here is a point A, and here's a point B. I'm going to connect them with a line segment, and I would like to be able to determine this distance. Denoted by D or D sub AB, whatever you want. It's okay, either way. So we want to measure this distance. Well, I have to find or establish the coordinates of A, right? It's x1, y1, and B, x sub 2, y sub 2. And we will form a right triangle. And all we need to do is use the Pythagorean theorem. To determine the distance. So obviously this is x1, and this is x2, and this is y1, and this is y2. Can anyone give us the measures for this picture that we have here? The measures of the legs. How long is the horizontal leg? It must be x2.
Minus x1.
Of course, thank you very much. It is x2 minus x1. What about this leg?
Y2 minus 1.
Y2 minus 1. That's all we really needed. And now we will be using the Pythagorean theorem. So whenever we think about the Pythagorean theorem, please do not say a squared plus b squared equals c squared. Makes no sense. If I tell you that a squared plus b squared equals c squared, you're going to say, what are you talking about? I have to tell you that a and b are the legs, and then it makes sense. right? If I don't tell you that the legs are denoted by A and B, what I'm telling you makes no sense. So the sum of the legs squared equals the hypotenuse squared, the longest side. The longest side squared is the sum of the squares of the measures of the legs. So obviously, this is x1, x2 minus x1, and y2 minus y1. We like to present the distance after we take the square root from both sides. When we take square root from both sides, we will use the square root principle and write plus or minus in front of the square root, but not in this case. Why? Why do you think I am going to omit the plus or minus here in front of x2 minus x1 squared plus y2 minus y1 squared? Why will I not write plus or minus? Correct. Thank you very much. The distance cannot be negative. Okay, so this is a distance formula. Question for you. Can I further simplify this? Can I further simplify this?
No.
Absolutely not. Very good. Thank you so much for saying that. Because a squared plus b squared is never the square root of a squared plus the square root of b squared. This is not possible. It would be incorrect. This is correct. This is correct. If it's a product or a quotient or ratio. But if it's a sum or a difference, you cannot split the radical. And this is a sum of two quantities. Very good. Coming back to the picture, somewhere right in the middle, there is a point called midpoint. And we can easily show that the coordinates of the midpoint are the averages of the two coordinates, x and y. So the average of y, x values, x1 plus x2, which is the average over 2, y1 plus y2, the average of y is going to be the y coordinate of the midpoint. So M is the midpoint. Okay, so now I'm going to select a problem, or you can select a problem. I'm trying to stick with what they recommended because otherwise, and also answer your questions, because otherwise we're not going to be able to finish. This is not what I wanted. I wanted, give me two ordered pairs. I just want to illustrate with two ordered pairs. I want to illustrate the distance and the midpoint. Just make them up. Doesn't matter.
32.
Also give me some negative.
4, -3.
Excellent. So we have 2 points. We came up with 3, 2, and 4, -3. And we want to determine the distance and the midpoint. The midpoint is the easiest and quickest. Add up the x values and divide by 2. Add up the y values and divide by 2. That's all you need to do. So what is the x coordinate of the midpoint? Yes, please. Yes, 7 divided by 2. Excellent. What is the y coordinate of the midpoint? Add them up and divide by 2. That's it. Now let's determine the distance. Any questions on the midpoint? Any questions on the midpoint? Okay. So I would recommend this. Remember, I always say to all my students, I'm showing you a method. If it makes more sense than the method you know, adopt it. If it does not make more sense than what you know, do not adopt it. Stay with your own. So what I recommend, first write the equation, the definition, the formula, the distance formula. Then what I like to do is identify x1, y1, x2, y2. And then write them underneath the corresponding formula, right? The corresponding entries. So under x2, I'm going to write 4. and then under x1, I'm going to write 3, and then -3 and 2. I'm sure this is very clear to all of you that you will never write something like this, right? How come that the answer would never be the square root of -47? No, because I'm adding two positive numbers, right? I'm adding two positive numbers. I'm adding two positive numbers, correct? No matter what I get, I don't care. They're positive, right? And then I'm adding them. So this will never be an option. Please remember that. Okay, so how much is 4 minus 3? How much is 1 squared? How much is -3 minus 2? -5 squared. So then the distance is the square root of 26. What is this?
Dang. So
Can anyone say that it's a circle? Make me happy and say it's a circle. Okay, it's an attempt to a circle. I got it. Okay. So anyway, this is the center. We denote the center by h comma k. That's the convention. And let's say this is a point A, x comma y, on the circumference of this potential circle. What do you think it's this? Or it looks like being? Yes, indeed, the radius. So, assuming that this is a circle, it has a center h comma k. It has many points on the circumference, and I just picked one as x comma y, and I connected the center to it with a radius. So now I would like you to give me, to use the equation, the distance formula, and write the distance between A and C. In that order. It doesn't really matter, but I'd like to write it as x2 minus x1, y2 minus y1. So I'm going to say that the distance equals x2 minus x1. Very good. Everything squared plus. Very good. And now I would like to square both sides. This is good enough, but I'll show you why we square both sides. So this will become x minus h squared plus y minus k squared equals r squared. This is the equation of a circle with radius r and center h comma k. The reason why we square is it's because it is easier to work with this equation like that in the form of the sum of squares than to just, it doesn't really matter. You can always square, or you can keep it as a square root and then square if you want to later. It doesn't matter really. Okay, we have three types of problems here. Of situations. And I would like to select from this handout. It's posted, as I said, I didn't make copies, it's 35 pages. And it's called Supplement Circles. Okay? So I'm going to show you a few problems. So this is on page 28 of the handout. And I would like us to choose any circle, A, B, C, or D, to identify the center, the radius, and write its equation. Please choose any of those.
C.
Right. Okay, I choose B. Whenever there is a tie, I choose. I don't know if it was a tie or not. Okay, so B. So obviously, I'll see that this is the center. I also want to determine the domain of the circle. And I also want to determine the range of the circle, not just the equation. So domain and range. Domain, of course, we remember that is measured on the x-axis, and I see it is between -1 and 5. Very good. So domain, -1 and 5. So this is, let me write circles, supplement, page 28. And we selected circle B. Okay, let's also identify the range from +2 to +8. 2 to 8. Okay. Center. The center is 2, I think it's 5. 2, 5. And now let's identify the radius. How big is the radius? 3 units. So this is one type of problem in which we're given the center and the radius and we're asked to find the equation. Can anyone give us the equation of this circle? X minus 2 everything squared plus yes? Yes? Squared equals 9. Very good. This is the equation of the circle with center 2, 5 and radius 3. So this is one type of problem. We identify where we are given the center. We identify where we are given the radius. We are asked to find the equation. Now, second type. So this is type 1. Type 2. Let's say we are given an equation. This one on page 29, part B. 29, part B. Top of page 29, B. So x squared plus y plus 7 squared equals 9. So we're given an equation, and we're asked this time, identify the center, and identify the radius, and also graph it. So all I have to do is compare it to x minus h everything squared plus y minus k everything squared equals r squared. I compare these two side by side, or one under the other, and I'll say, oh, okay, so the center is and the radius is, and then we'll graph it. So what is the center and what is the radius? 0 and -7, excellent. And the radius? Very good. So let's make sure that everyone understands this, right? See, there is nothing subtracted from x. It's like x minus 0 squared. Therefore, h is 0. Now, we are comparing these two, but there must be a minus. In the formula, there is a minus, which makes this a -7, which makes y minus -7. Therefore, k is -7. Is this clear for everyone? Yes? Okay. Let's graph it now. Zero, -7 happens to be on where? On the y-axis, very good. 1, 2, 3, 4, 5, 6, 7. I start with the center, and I go north, east, west, south, 3 units away. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And yes, you are going to say that this is a circle. Please. And even if you don't, it's still a circle. I declared it a circle. Okay, so in type 2 of a problem, right, second possibility, I'm given the equation, I'm asked to identify the radius and the center and then graph it. Well, the third type is a totally different story. By the way, before we look at third type, so what is the center of this circle? 0, comma 0. Very good. Awesome. Okay. So this is the third type. On page 30, the last 3. Please choose. Because you're going to have to work on the other ones. You want to work on h. Very good. Let's do that. So x squared minus 6x plus y squared plus 10y minus 65 equals 0. First of all, the question is asking us, is this a circle? I'm not sure yet. Okay? I'm not sure. I will have to compare it to the following. X minus h squared plus y minus k squared equals r squared. If somehow I manage to change this into something like this, and r, or this portion on the right-hand side, is a positive number, not 0 or negative, in other words, then I will say, yes, it's the equation of a circle. So the right-hand side cannot be 0. If it's 0, the circle is a point, just a center. If it's negative, that's a totally different story. It's not a circle. The right-hand side. If the right-hand side is 0, the circle is a point. If the right-hand side is negative, that's not a circle. Okay, so then we know something, a technique from the past in algebra adventures that will allow us to rearrange this in this form. What is that procedure called? Say it again.
Would you like to do it?
In a way, it uses grouping also. But there is something else I need. I'll help. Thank you. Completing the square. We have to complete the square with which variable? X. And we have to complete a square with which variable? Exactly. We have 2 completed squares in the equation, right? One with x alone, the other one with y alone, and on the other side a term 3 of variables. So then, let's look at these 2, and then look at these 2, and see what they are missing, because they are missing the third term. So how do I determine the missing term that goes with x squared minus 6x? Here is the step-by-step procedure to refresh your memory. Number 1, completing the square, first step. Identify the middle coefficient. The middle coefficient in x squared minus 6x is? The middle coefficient is?
0.
The middle coefficient will always be taken with a sign in front. I cannot separate 6 from its sign. So one more time, this middle coefficient is? Very good, very good. Number 2, divide it by 2. So negative 6 divided by 2 is? Very good. Number 3, square this result. What do I get? Very good. And number 4, add 9 to both sides and complete the square. These are the 4 steps of completing the square. Let's review them. First, I have to make sure that everything is in descending order, right? To identify the middle coefficient, I need that. They are. The middle coefficient is -6. I have to divide that number by 2. Then I have to square the result. I square -3, I get 9. And this is what I add to both sides. So going back to the equation, I'm going to copy it here one more time. We're going to add 9 to both sides. Adding 9 to both sides of an equation does not change the equation or the solutions. It changes the outlook if you want, but not the solutions. So now let's look at these two. Middle coefficient, please. 10 divided by 2. And we squared 5. What do we get? Very good. So we're adding 25 to both sides. Okay, can anyone tell us what to replace this by? That's why we reviewed on the first day of classes this special product. It's one of those 3 that we have an agreement on. Everything squared. Very good. So this is done. All these 3 terms are here now in x minus 3 squared. Good. So now please do the same thing for y squared plus 10y plus 25. Anyone? 1 plus 5 squared because they're all positive. Very good. -65 moves to the other side with 9 and 25. So 65 plus 25. Right? And plus 9. Okay. So now let's identify the center and the radius. Careful. One is negative here and the other one is positive. So the center is 3, -9 and -5, and the radius is square root of 99. Any questions? Any questions? Do you think we need another problem like this? Yes? Okay, so let's choose one more. Any questions on completing a square? Any questions? Okay, so let's take a look. Any preference? Okay, G was first. G was called first. X squared minus 8x plus y squared equals 27. Is this square with y already completed? Yes, because there is no term with y itself. There is y squared, but there is no term with y. So there is nothing we need to do for y. So in this case, we only complete the square for x. What do we need? Middle coefficient is -8. We divide it by 2. We get -4. We square -4. And this is what we need to add to both sides. So now the left-hand side becomes, we need to incorporate these three into a perfect square. X minus 4 squared, exactly what we squared to get 16, of course. Plus y squared equals, is it 43? Good. Okay, we need the center and the radius. And that's all we needed from here. That's why for these four problems, I just didn't make a copy. So what we have as the center? 4 comma 0, excellent. And the radius? That's it. Very good.